Dear students, in this class we are going to discuss root mean square value. It is also known as effective value. So what is the definition? The effective value or RMS value of an alternating quantity, whether it is a current or it may be a voltage, is that it is a steady current or DC current which when flowing through a given resistance for a given amount of time produces the same amount of heat as produced by the alternating current when flowing through the same resistance for the same time. Okay. Now, if you consider a resistance R, through this resistance, if a I amperes of AC current is flown, and the amount of heat produced will be I AC square into R. Instead of AC current, if you flow some amount of DC current for the same amount of time through the same resistance, in order to produce the same heating effect, what should be the magnitude of this DC current? That value is called as RMS value or effective value. And mathematically, the expression for RMS value is given by I RMS equal to square root of I1 square plus I2 square plus I3 square so on plus IN square divided by N. Let's see the derivation of RMS value of sinusoidal current waveform. Let the instantaneous current I equal to Im sin theta. As it is sinusoidal current waveform, the instantaneous current I is given by Im into sin theta. If you take current on y-axis and theta on x-axis, the current waveform will be a sinusoidal wave as we have drawn now. So it is 0, the positive cycle ends at pi and the cycle will complete at 2 pi. Now, in order to get the I square, we need to square the current waveform. So this is I current waveform. Now we need to get the I square. So it is 0 to pi, the values of I are positive. So square of that values, the waveform will be like this, and from pi to 2 pi, current values are minus, so it is minus I square minus I whole square is again positive value, so minus into minus again we are going to get positive. So from pi to 2 pi also the I square waveform will be like this. This is I square waveform. Now, in order to find out the RMS value, we need to find out the area under the curve. So for finding the area under the I square curve, let us consider a small strip which is having a width of d theta in this d theta width, the instantaneous current let us take as I square. So area of the strip is given by I square into d theta, length into breadth. Now area of cycle of cycle of squared current wave, I square wave of cycle area is given by integral 0 to pi I square d theta. So I is Im sin theta. So if you substitute I value here, we are going to get 0 to pi Im square sin square theta d theta. As Im is independent of theta, we can write Im square outside the integrals 0 to pi sin square theta d theta. Now that area of cycle of squared current wave is given by Im square integral 0 to pi sin square theta d theta. So you have to simplify it. If you implement trigonometric relations, then you can get Im square integral 0 to pi. The sin square can be written as 1 minus cos 2 theta by 2 d theta. So 2 is also independent of theta, so I can write outside Im square by 2 integral 0 to pi 1 minus cos theta d theta. So if you make integration Im square by 2 integral 1 d theta is theta minus cos 2 theta. So cos 2 theta is sin 2 theta by 2 with the limits of 0 to pi. So Im square by 2, here limit is pi minus 0 0 0, so everything goes to 0. So we are going to get Im square into pi by 2 as the area of cycle of the squared wave. Now if you find out the RMS value, it is given by square root of area of cycle of square wave, that is squared current wave, squared current wave divided by half cycle wave length, half cycle base, which is equal to square root of Im square pi by 2 divided by half cycle base is pi. So pi gets cancelled. So we are going to get 1 by root 2 into Im. 1 by root 2 is 0.707 into Im. Therefore, the RMS value IRMS equal to 0.707 times the Im. So this is the expression for RMS value of sinusoidal current. Similar way, we can get the expression for RMS value of voltage, which is given by 0.707 times the Vm. Thank you.